Okay, Assalamu alaikum and good afternoon, students. Today we will study addition of vectors. So our topic is addition of vectors. Of vectors. So before moving forward, I just want to ask, what is an additional feature of a vector? So Sarah Yasser, could you please describe what is the additional feature of a vector?
Sorry, sir, could you repeat the question?
What is the main feature of a vector?
Uh, I don't know.
Aiza Batul,
It has angles. There,
direction. Direction. So
yeah.
vector has a direction, right? So while adding the scalar, we just add magnitude, and while adding the vector, we add both magnitude and direction. So in vector addition, we need to account the direction. So this is the main thing. In vector addition, direction would be accounted along with magnitude, right? So in vector addition, we have to consider both direction and magnitude. Aiza Batul and Sarah Yasir, are you clear about this? Can we move forward?
Yes, sir.
Okay. So let's consider a past paper question. Question is forces of 3 Newton and 4 Newton. There are two forces. F1 is 3 Newton and F2 is 4 Newton, and they have described as act as shown in diagram. The diagram is given in so 4 Newton and 3 Newton. Arrow indicates the direction. Okay. So may I ask what is the angle between 3 Newton and 4 Newton force? Aiza Batul, could you please describe what is the angle between these two forces?
Sorry, can I tell?
What is the angle between these two forces? What is the angle?
Can
Yes, please.
I tell? 90 degrees.
Yes, 90 degree. Okay, right. So you know, for for graphical method of vector addition, we use head to tail rule. Head to tail rule, right? So may I ask just a question? Uh, can we add like this? I draw a red line. Is it all right?
Yes, sir, because 3 Newton is the head and 4 Newton is the tail.
I'm Aiza Batul. What do you think? The is the red line is the resultant of two vectors.
Yes, sir.
I am afraid no. The thing is, here we are joining the head of two vectors. This is the head of 4 Newton. This is the head of 3 Newton. So we can't connect head of two vectors. Okay. What we
Okay,
will
sir.
do, is that clear, students? This is not correct. Here we are connecting the heads of two vectors, which is against the rule, head to tail rule. You know what we will do? We will shift the vector. We will shift shift 3 Newton vector. How we can shift? We can like this. You know, when one vector is shifted, there is no change in its direction and no change in magnitude. No change in direction and no change in magnitude. Actually, you can say here 3 Newton is upward earlier, after shifting direction is upward. Magnitude is same, earlier it was 3 Newton, after shifting it was 3 Newton. Students, are you clear? We can shift a vector from one place to another place, as long as there is no change in its direction and no change in its magnitude.
Sir, one question.
Yes,
What
please.
if I draw? What if I do 3 Newton over here?
Okay. So
So then I can make. So then it will be different, right?
no, same thing. No change in direction, no change in direction, right? The thing is, again, actually we have to connect tail of the one vector to the head of the other second vector. This is the main reason. We have to connect tail of the first to the head of the second. So for
So
that,
sir, this is the head, and this is the head. This is the tail, and that is the head, right? So we can connect this. No.
actually, tail of the first to the head of the second. Okay, same thing, same thing. You are very right. And this would be the uh, let me and this would be the direction resultant. I am going the same thing like this. Same magnitude, same direction resultant. This direction and this
Oh,
angle would be the same. Sara Yasir, you did correct. Aiza Batul, do you
all
understand?
right, sir. Thank you.
Aiza Batul, do you understand? I think you have some
Yes, sir.
very.
Yes, I can.
Is that clear, Aiza Batul, for you?
Yes, sir.
Okay. Can we move to the other question? Second question.
Yes.
Yes, sir.
Okay. Second question is, uh, which diagram correctly shows the addition of 4 Newton and 3 Newton force? Okay. Second is addition of 4 Newton and 3 Newton force. Okay. There are four options. I have already sent you these questions. Uh, Sarah Yasser, have you got MCQ's question? So, A. Option A, uh, this, this, and this. 4 Newton, 3 Newton, and 5 Newton. Option B is this, this, and this. 4 Newton, 3 Newton, and 5 Newton. And option C is this, and this. 4 Newton, 3 Newton, and 5 Newton. Oh, okay, students, please have a look. What do you think? Which one is the correct option? We will discuss one by one, and also we will discuss what are the the mistakes or errors in other options. Sarah and Isa, could you please identify which one is the correct option? Which one is the resultant of 3 Newton and 4 Newton?
Sir, I think it's B.
Okay, it's B.
I think it's A.
Okay, it's A. Students, let me explain one by one. Uh, Option A is a correct answer. How? Let me explain. And also we will discuss the mistakes or error. You know, this is 4 Newton, this is tail, and this is head. 3 Newton, this is tail, and this is head. So, tail of first is connected to the head of the second. Arrow is towards this. Now, how resultant magnitude of resultant is 5? By using Pythagoras theorem. Are you familiar with Pythagoras theorem, students?
Yes, sir.
Yes, sir.
Okay, 4 square base plus it is 16 plus 9 underwood, which is become 25. Underwood 25 is 5. So resultant would be 5. Option A is the correct answer. Now let's see what's wrong with option B. What's wrong with option B? 4 Newton, this is tail, this is head. 3 Newton, this is tail, this is head. In option B, they are not connecting the tail of the first to the head. They are connecting the head of the second to the tail, which is wrong. Direction is wrong. Arrow should not be downward. Arrow should be in upward direction. Sarah Yasser, do you understand this?
Yes, sir. But sir, I have a question.
Yes, please.
Isn't it head to tail? So wouldn't the Arrow go downwards.
Actually, in writing, it is it generally speaking the rule is head to tail, but we connect tail of the first vector to the head of the second vector.
Got it.
Graphical method. Okay. Now let's see what's wrong with option C. In option C, there is a head, tail, head. You know, sorry. On option C, there is tail and there is head. In option C, they are connecting the heads of two vectors. Can you identify option C?
Yes, sir.
They are connecting the head. In option D, they are connecting the tail of two vectors. Can you identify? This is tail, this is also tail. In option D, they are connecting the tail of two vectors, which is wrong. So option A is a correct answer. Students, do you understand this?
Yes, sir.
Can we move
Yes, sir.
can we move forward? Okay. Now let's discuss question number 3, which is very much important. Question is, when there is no wind, the engine of the airship pushes due north at 20 meter per second. So velocity is 20 meter per second due north. Okay. The wind is blowing from west at, so wind is blowing from with the speed of 12 meter per second from the west. Here there is a technical point. Students, when a wind is coming from west, what would be its direction? A wind which is coming from west, what would be its direction of wind? In which direction it is going?
Eh?
A wind which is coming from west, in which direction wind is going? Sarah, would you like to add?
This direction. This direction.
East. Coming from west, it is,
Like yeah.
yes,
Oh no, like it would go this side. This way.
east. Okay. Coming from west, so it means due east. Aiza, is the all right? Aiza Batul, do you understand this? Aiza Batul, please unmute your mic.
Yes, sir.
Do you understand when a wind is coming from from west, it will be directed towards east. Okay.
Yes, yes, sir. I understand.
Now I am going to. This is north, 20 meter per second. This is east, 12 meter per second. Okay. So to find out which vector diagram correctly shows how the resultant velocity, to find out the resultant. So here we can't connect the heads of two vectors. So what we are supposed to do, we will shift, we will shift one vector. Either we can shift, we can shift 12 meter per second towards this, okay. On the other way, we can also shift 20 meter per second, and this is the resultant, tail of first, head of second. So tail of first is connected to the head of the second. This is the resultant. Student, is that clear? Am I am I clearly
Yes,
audible?
sir.
Am I clearly audible for
Yes, sir.
Sarah and Isa? Okay. So let's
Yes,
start.
Yes,
sir.
sir.
Okay, let's start from the theory question. This question, we were on this question. Student, a parachutist of total weight 950 Newton falls vertically at constant velocity. So velocity is constant. It means acceleration is zero and resultant force is zero. Do you agree?
Yes, sir.
Okay.
Yes, sir.
So state the size and direction of resistive force. What would be the size or magnitude of resistive force? Could you please give the answer? Size of resistive force and direction of resistive force. Please write your answer in a chat box. Isa and Sarah, please write the answer. Would you able to see question on your screen?
Yes, sir.
Okay, write the answer. It's a logical understanding, no need to do calculation. Direction of resistive force is always opposite to the motion, as body is falling vertically downward, so you can easily understand from it. Oh. Sarah Yasser, please reconsider your description, please. A parachutist of total weight falls vertically. So parachutist is falling vertically, so weight is acting vertically downward. So resistive force will act opposite to the motion, vertically upward. As weight is 950 Newton, so direction magnitude of resistive force would be the same as weight, because for constant velocity, resultant force is zero. Yes, upward, you are very right. And what would be the magnitude? Magnitude would be the same as the weight, because when velocity is constant, acceleration is zero and resultant force is zero.
Sir, how is it upwards?
Okay, let me explain. Resistive force or drag force. You know, drag force, let me explain. You know, this is parachutist. So weight would be vertically downward and drag force is opposite to the motion. FD would be opposite to the motion, right? So resistive air resistance is opposite to the motion. Air resistance or all resistive forces, friction, air resistance, they are opposite to the motion. As parachutist is falling vertically downward, air resistance would be upward. As velocity is constant, acceleration would be zero. Acceleration would be zero. Acceleration zero mean resultant force also zero. Resultant force also zero. Okay. So resultant force would be zero when downward force is equal to upward force. Force is equal to upward force. Downward force is equal to. Sara Yasser and Aiza Batul, do you understand this information, this logic?
Yes, sir.
When object is moving
Yes,
with
sir.
when object is moving with constant velocity, its acceleration would be zero. When acceleration of an object is zero, the resultant force acting on it is zero. Resultant force zero means downward force is equal to upward force. Two forces equal in magnitude, opposite in direction. Can we move forward?
Yes, sir.
Okay. At a certain height, the wind starts to blow and parachutists move horizontally at a velocity of 4.5 as he continues to fall. Use a graphical method. Okay. So we have two vectors here. One is 6.5 vertically downward. We, as velocity is a vector, So we have two vectors here. Let me explain how we can find out resultant velocity. One is vertical and one is horizontal. We have two velocities. One is vertical velocity. What is the magnitude of this vertical velocity? Sarah, could you tell me what is the magnitude of vertical velocity?
Uh, the same, sir?
No, no. Vertical velocity, I am not asking about a force. I am not asking about a velocity. Vertical velocity has a component 6.5 meter per second. Okay. And they ask at a certain height the wind starts to blow and parachutists move horizontally. So horizontal velocity, horizontal velocity,
It says here we should work in teams.
horizontal velocity would be 4.5 meter per second. And the angle between horizontal and vertical, as we know, is 90 degree. Okay.
Yes, sir.
So how we can represent? First, we will take a scale. So please, every student, please take a scale. You you can take a scale by your own choice. Here, Aiza and Sarah, what do you think? Is 1 centimeter is equal to 1 meter per second? Is all right? Is okay? Scale for this question. 1 centimeter length.
Yes, sir.
Okay. So what we will do?
Sir, should we do 0.5 centimeter equal to 0. Meter per second instead?
Sorry. Say it again.
0.5 centimeters.
0.5 centimeter. Yes, is equal to
0.5 meter per second.
yes 0.5 meter per second. Same thing. Multiples or sub multiples. Okay. So for 1 meter, 1 centimeters for 6.5, we will plot this line. Okay. The length of line would be 6.5 centimeter and its direction would be vertically downward. Right. And the horizontal, for horizontal velocity, the length of line should be 4.5 centimeter. 4.5 centimeter, and angle between them is 90. So this is tail and this is the head of second vector. So we can connect, we can connect the tail of first to the head of the second. The tail of first to the head of second. And we are supposed to do put double arrow. Now please, using a scale or using Pythagoras method, could you please find out the magnitude of resultant? Student, please find out the magnitude of resultant by using graphical method or by using uh, Pythagoras theorem. Students, are you doing working?
Yes, sir. Sir, 7.9. 7.9.
Okay. 7. Uh, you got your answer by graphical method or by using the Pythagoras theorem?
Pythagoras theorem.
Okay, right. So, uh, could you please do it by graphical method as well? Do you have a geometry box with you?
Yes, sir.
Please do it by using the graphical method as well. Aizabatu,
Sorry, sir. Could you tell me how to do it?
just first make a straight line perpendicular 6.5 centimeter length, then base 4.5 centimeter length. Arrows are uh, 6.5 has an arrow vertically downward, 4.5 is horizontal, and we have to connect the tail of first vector to the head of second vector, and then find out the length of the diagonal hypotenuse.
Using a sphere?
Yes,
It's 7 point. It's 7 point. Wait.
like more or less same.
It's 7 point. Yeah, it's 7.9.
Okay, so we can say the magnitude of resultant is 7.9 meter per second. Okay, magnitude of resultant is 7.9 meter per second. Now let's talk about the direction, as resultant has a magnitude and direction as well. Aiza Batul, what's your final answer? Are you doing solving this question by graphical method?
Yes, sir, I've done it at 7.9.
Okay. Now please find out the direction. You know, for direction, we have two options. Let me explain. Either we can measure this angle, we can measure this angle, okay? And either we can measure this angle. But how to describe? Yes, in the last class, we have watched a video how to describe the direction of an angle. If you want, we can watch that video again, no problem.
No, sir. No need.
Do you have protector with you? D or protector?
Yes, sir.
Please find out the angle. Yes, please.
One
What?
minute.
Could you please tell me the angle? Aiza Batul,
Sir,
please.
60 degree.
60 degree. Which angle? With the vertical or with the horizontal?
Sir, I measured the 4.5 one.
Okay,
I measured
right. Could you
this.
please measure the second one as well?
All right.
Aiza Batul, what's your
Sir,
finding?
it's 35 for the
Okay.
other angle.
So how to represent 35 degree with the vertical and 60 degree to the horizontal? Okay. Is that clear, student? Aiza and Sarah, any question regarding today's class? What what we have done in today's class? Some we have discussed some MCQs and also we have solved a past paper question. Are you clear about that?
Sir.
Yes, sir.
Aiza Batul and Sarah, any question regarding today's class?
No, sir, it's all clear.
Okay, take care yourself very much. So inshallah, next class would be on Saturday, right? So please do some addition of vectors question by yourself. So we will try to discuss dynamics on that class, right? Thank you very much.
Allah Hafiz, sir.
Allah Hafiz. Goodbye.